Hello, this is Miss Moore, and today during chemistry we're going to discuss acid-base reactions. All right, and let's start with a quick review, I guess, of what we mean by strong acids or bases, either way. Strong acids or bases. So if we have a strong acid, what makes it a strong acid? A strong acid is something that's going to completely ionize, right, in water. So if we had some strong acid, HX, and we mix that with water, we end up with H3O and Rx minus. Okay, a strong base also. The reason it's strong is because it completely ionizes. So when we add some base, I don't know what, AOH, I guess, to water, we're going to end up with our cation A and OH. So now let's mix together our strong acid and our strong base. So we'll take the H3O plus the anion from the acid and the cation plus the OH from the base. So what's going to happen here? Well, the H3O and the OH are going to interact, giving us water. And then what about the anion and the cation? What's going to happen there? Well, recall that the conjugate base of a strong acid is going to be weak, right? So this is a weak conjugate base, which means it's really not going to do too much. And the conjugate acid of a strong base is also weak, which means that our cation and anion are just going to continue floating around. So if we think about net ionic equations, our ions will cross out. So this is kind of cool. All of this is to say that a strong acid plus a strong base basically produces, not H3O, produces water. Okay, the way I wrote this example here, it looks like if you mix together a strong acid and a strong base, you end up with simply water, which is a neutral solution, right? And that could be true if I have exactly the same amount of acid and base. And more specifically, not only the same amount of acid and base, but the exact same amount of hydrogen and OH. Okay, so that doesn't normally happen. So let's see what we would do under a different circumstance where our acid and base aren't exactly equal. So here's a quick practice problem. If we have 200 milliliters of a 0.25 molar HCl solution, which is a strong acid, it'll completely ionize, and it's mixed with 150 milliliter of a 0.5 molar NaOH solution, strong base, completely ionize, what is the pH of the final solution? Okay, and the pH is the concentration of the H plus ions present. We could also calculate it backwards with the NaOH ions present. So if we write our little reaction, what would be happening if we mix together HCl and NaOH? Remember that HCl is a strong acid, right? So it's going to be Cl plus NaOH. The HCl is going to completely ionize, as is the NaOH, right? So we're going to end up with, we're going to have our Cl minus and our Na plus, and we're going to have water. But are we going to have any H left over or OH left over? So what we need to do is we need to figure out how many moles of H there are, how many moles of OH there are, to figure out how much they reacted. All right, so if we start with the HCl, we have remember that molarity equals moles over liters, and we know the molarity and we know the volume, the liters, so we should be able to figure out how many moles of HCl we have, which also tells us how many moles of H we have. So we're going to have an 0.25 molar solution of HCl equals, we don't know how many moles, and a 0.2 liter solution. And that will give us 0.0500 mole of HCl. And because this completely ionizes and HCl is monoprotic, that means that we also have 0.005, whoops, too many zeros there. Try that again. 0.0500 mole of H plus, or H3O if you prefer. Okay, let's try this again. We'll do this now with the NaOH. So NaOH, we have a concentration of 0.50 molar, or mole over liter, equals, we don't know how many moles, and 0.150 liters, giving us 0.075 mole NaOH, which is also means 0.075 mole OH. All right, so hopefully you can see that we have actually more OH than we have H plus, right? Which means in our reaction up top, we would really end up having some OHs left over. So to figure out how much we have left over, we could take the, let's see, we can say that we have 0.075 mole of OH, and that's going to react with 0.0500 mole H plus, which gives us, that means we're going to have 0.025 mole of OH left over, right? We're going to make this much of it will end up being water, right? 0.05 moles. We'll make 0.05 moles of water, and we'll have 0.025 mole of OH left over. All right, we now know the number of moles of OH. What we're looking for is the pH, which means we need to switch those moles or convert the moles back to concentration. Okay, so remember molarity equals mole over liters. So we know the number of moles is molarity equals moles. We know the number of moles of OH. The volume, remember we mixed these two. So we have 200 milliliters and 150 milliliters. So we now have, changing that to liters, right? So we now have 0.2 liters plus 0.15 liters. And that would give us a concentration of 0.071 molar. Okay, so that is our concentration of OH minus. All right, I need a little bit more room here, so let's move on to the next page. So we have a concentration of OH minus of 0.071, I think. Is that right? Yes. Okay, and that is our concentration of OH minus. If we would like, we could get the POH from that, right? Remember, POH equals negative log concentration OH, which gives us a POH of 1.15, and POH plus pH equals 14. So our pH would be about 12.9, which would make sense because we had leftover OH, right? Which means our solution should be basic. Okay, so we've talked about what happens when you mix together a strong acid and a strong base. But what if we were to mix together a weak acid and a strong base? Okay, so a weak acid, it hardly ionizes at all, right? Very little ionization. Okay, and the strong base completely ionizes. So let's mix together a weak acid like HNO2, which is barely going to ionize at all, and NaOH, which pretty much completely ionizes, giving us Na plus OH minus. Okay, so when we mix them together, we'll have something like HNO2 plus Na plus OH minus. And remember that Na plus is a weak conjugate acid, so it's going to do just about nothing. Okay, let me make a little bit of room right here. So what's going to happen in this particular case is the OH is going to steal the H from the acid, and so you're going to end up with water and NO2 minus plus our sodium ion, which we can actually, thinking anionic, we can ignore that guy. Okay, last topic. What if we now had a strong acid mixed with a weak base? So again, what makes a strong acid strong is that it completely ionizes, and a weak base would barely ionize, or very little. Okay, so let's see. Our strong acid, we'll use hydrochloric acid, and our weak base, we will use ammonia. So our strong acid is going to become H minus, or if you prefer H3O, no, H plus or H3O plus, and Cl minus. So when we mix these together, we'll end up with H3O plus Cl minus plus our weak base. So what's going to happen here? Well, the extra H here could be donated to either the Cl or the NH3. Cl is a really, really weak conjugate base. It's basically going to do nothing. Okay, so what's going to happen is that the NH3 is going to accept the extra H. So we're going to end up with NH4 plus water. Well, folks, that's it for today. Have a good one.